Hi everyone, I hope you're okay. And I really hope that guys the videos are helping you out. Before we even start the video guys, please do share this video to your peers. A thing or two that I'll mention here, I believe that it will help them either elevate their knowledge in organic chemistry, help them to prepare for an upcoming exam or a test. Uh, yeah, and please don't forget to like, comment, ask questions on the comment section. You are more than welcome to do so. And most importantly, guys, please do help us grow the channel by just subscribing. Okay, learners investigate factors which influence the boiling points of alcohols. They use equal volumes of each of the alcohols and heat them separately in a water bath. The temperature at which each boils is measured. The results obtained are shown in the table below. Okay. We are given boiling point of butane 1-ol, pentane 1-ol, and hexane 1-ol. We are just given straight chain alcohols, and all of these alcohols are primary alcohols. It's very important, guys, that all of them become primary alcohols, because the positioning of the OH ion tempers a lot with the boiling point. So if all of the alcohols we have are primary alcohols, it makes this a fair investigation. Okay. First question, you must define the term boiling point. Boiling point is a temperature at which the vapor pressure of a substance is equals to its atmospheric pressure. And then 3.2, what properties of alcohol requires them to be heated in a water bath? Okay, they are heated in a water bath because alcohols are highly flammable, or you can say they are highly volatile. And then 3.3, we are told that the boiling points of the alcohols are compared with each other. What structural requirements must the alcohols meet to make it a fair comparison? Firstly, for the fact that they used primary alcohols only, that makes it fair. And secondly, we are only using straight chain alcohols. They do not have side chains, because once you have a side chain in a compound, that tempers a lot with the compound's boiling point. Okay, and then 3.2, they want us to fully explain the trend in the boiling points. We can see that hexane 1-ol has the highest boiling point compared to pentane 1-ol and butane 1-ol. Yeah? The difference over here, guys, is the size of the molecule. Why am I saying that? Because if you can check butane 1-ol has 4 carbons and 10 hydrogens altogether. However, pentane 1-ol has 5 carbons, 12 hydrogens, and obviously between those two compounds, pentane 1-ol will have greater molecular mass. Why? Because it has CH3, which is added altogether, and then for hexane 1-ol, hexane 1-ol has 6 carbons and 14 hydrogen atoms with an oxygen as well. So hexane 1-ol will have a greater molecular mass. Why? Because if you would calculate the molecular mass for butane 1-ol, that's C4H10 with an O, we'll simply get, let me check, I have 4 carbons. Each carbon has a molar mass of 12, so that's 4 times 12 plus 1 times 10 plus 16. This will have 74 grams per mole. And then pentane 1-ol is C5H12 with an O. It's C5H12 with an O. this will be 88 grams per mole. And then for the hexane 1-ol, we'll simply get 102 grams per mole. You can see that, guys, the molecular mass for these compounds are not the same, né? So that's why there is a difference in boiling point. The one with the greater molecular mass will have stronger intermolecular forces, and hence it will have a higher boiling point. But let's answer that so that we can be able to chow marks, né? We can see that point number 1, hexane 1-ol has a greater molecular mass compared to the other two together, and hence the intermolecular forces that exist in hexane 1-ol will be stronger than the others. So hexane 1-ol has stronger intermolecular forces, and then more energy will be required to separate the bonds in hexane 1-ol, and hence hexane 1-ol has a higher boiling point. That's how, guys, we're supposed to answer. You don't have to write paragraphs, né? Just get straight to the point. Okay, 3.4. How will the boiling point of hexane 1-ol be affected if the volume of hexane 1-ol is doubled? Choose increase, decrease, or remain the same. By changing the volume of hexane 1-ol, we are not affecting the boiling point of hexane 1-ol. Excuse me. Okay, and 3.5, we are told that in another investigation, the learners compare the boiling points of hexane 1-ol and hexanal. Hexane 1-ol is an alcohol, we know that, and hexanal is an aldehyde. Together, this is an alcohol. However, this one over here is an aldehyde. We are comparing two compounds that come from two different homologous series, and their functional group also differs. Together, alcohol has hydroxide ion, and then hexanal has a formyl ion. Together, so write down the independent variable. The independent variable for this comparison, you can say the functional group. The functional group is the independent variable, because we still have the same number of carbons on our longest chain. We still have 6 carbons. So the only changes that we have is the functional group. Okay, and then 3.5.2. They find that the boiling point of hexane 1-ol is higher than that of hexanal. Fully explain. Okay, hexane 1-ol has hydrogen bonds, has hydrogen bond, which is the strongest in all the pool of intermolecular forces. And then hexanal has dipole forces. Are you together? So since hydrogen bond is stronger than dipole, it simply means that hexane 1-ol has stronger intermolecular forces compared to hexanal, and hence hexane 1-ol requires more energy to separate the bonds, and then that's why hexane 1-ol has a higher boiling point. Okay, we are contrasting between two organic compounds, né, guys? Firstly, state the difference. Since they come from since they have different functional groups, they will have different intermolecular forces. Are you together? So we'll simply say that hexane 1-ol has hydrogen bond, and then hexanal has a dipole forces. Secondly, state which one between the two has stronger intermolecular forces. Hexane 1-ol will have stronger intermolecular forces. Thirdly, talk about the energy. We'll simply say that hexane 1-ol will require more energy to separate the bonds, and then that's why hexane 1-ol will have a boiling point. Are you together? If I wanted to contrast between the two and I wanted to make hexanal, which is an aldehyde, my point of reference, the first statement wouldn't have changed. Yes, I would have said that hexane 1-ol has hydrogen bond and hexanal has dipole forces. Are you together? But remember that now I am contrasting using hexanal, which is an aldehyde. Yeah? The second point would have been hexanal has weaker intermolecular forces compared to hexane 1-ol. And then the third point would be hexanal will require less energy to separate the bonds. And then the last point will be hence hexanal has the lowest boiling point between the two. Are you together? So when I wrote here, my reference was hexane 1-ol. It doesn't mean that it has to be like that always. Ne? You can contrast using hexanal as well. Just stay tuned, guys, and wait for more videos. Bye.